Hello, good morning everyone. I'm Bhubanesh. In this session, we'll talk about the data and field survey requirements of the master plan. So, like yesterday, Arpit sir has also iterated about the uh, different kinds of data which is required from various stakeholders. And there are two types of data that mostly we will be procuring during the river basin master plan, as this forms the basic foundation of doing a river basin master plan. Without the data which is primary data and both secondary data, we cannot go forward with any kind of the study of hydraulics and hydrology. So the first is primary data, which consists of our survey, the topographical survey, bathymetric survey, and lab testing of soil and water uh, in the soil and water labs. And next is the secondary data, which is going to be procured from different stakeholders, state stakeholders, and the different central departments, which will be used in conducting the hydraulic and hydrology assessment of a river basin. So first, why do we need to do soil testing of the river beds and bank to assess the infiltration and the permeability of the soil, and also it supports the irrigation planning and about the land suitability analysis, which means to uh, to test the soil for different types of crops to be planted over the area, over the command area. And also it helps in the design of our soil conservation and recharge groundwater and all recharge measures. And same for the water testing. It identifies the pollution sources and our stress, the river stretches in the basin. And also it will guide us with the planning of the water supply systems and also the ecological flow planning. This slide will show how we will collect the soil sample. Mostly the soil sample is collected for every constant intervals, like per 10 kilometer, per 30 kilometer, as per the requirements of the basin. Where there are plain areas where there is no undulating terrain, we prefer mostly a distance of around 50 kilometers on the main stretch of the river. But if there is an undulating terrain and the topography changes for every, like, let's say around 10-20 kilometers, then we have to minimize the gap of our soil that soil sampling areas. These are some test parameters that we usually do during the testing of soil. And the test method also is also given the relevant IS codes for all the test parameters. Next is the surface and groundwater sampling, and this also requires process which is which should be followed. Different this BIS or that standard protocol should be followed while collecting the samples. And if the results, the test results will help us determine the quality of the groundwater and the surface water, and will help in planning of irrigation and other drinking purposes. These are some test parameters that we usually do for surface and groundwater, and the relevant test methods, the relevant IS codes are also mentioned there. Now for the secondary data requirement, as also briefed by Arpit sir yesterday, we usually require different types of data sets for various for various validation during the process of preparation of master plan. First is the digital elevation model, which will be developed from the data which we are capturing through aerial survey and bathymetry survey. So this and then the next is the river network and catchment boundaries. This will also be done through the secondary data, and also it will be done through by cross-checking with the data that we have captured using LiDAR technology and the GGPS technology. And the other data like the hydrology data, hydromet data, rainfall data, temperature data, all the this hydrological parameters will be needed for conducting a good hydraulic study, and also a reliable hydraulic study which is which aligns with the real-time scenario. And also we will collect data regarding the irrigation and other reservoir data, the hydropower data. Why we are collecting the data and we are giving we are giving importance on this data, because like whenever we project some potential projects after completion of the river basin master plan, sometimes it might happen that that the basin has already the project at that area, but we haven't received the data, or we haven't got the data from the department. Then we will also propose the Brahmaputra board, let's say, who is preparing the master plan as of now, will propose potential projects at that area. And sometimes what happens is like the projects overlaps because of the receiving of the data. So certain follow-ups and very multiple follow-ups and multiple meetings with the stakeholders and coordination with the nodal officers which are given will be done in the process of preparation of master plan. And this these data sets are also required for validation of our hydraulic study, like the discharge data, which is for calibration and validation of our study which we have done, and the historical floods and drought records, which will serve us in projecting the future risk assessment for the scenario assessment. These are the process which we usually do for the validation of data collection process. First, the executing entity or the executing organization of the river basin master plan shall initiate the formal data request through letters or mails, and in the process of collection we will follow up with the nodal officer which is engaged in this process, so that there will be streamline of collection of data. Because in a department, all the data are not there. In the division also, most of the data is there, and we have to collect, and we require that data for projecting a real scenario that is happening in the river basin. And from here, this is the requirement of the topographical survey and the bathymetric survey. Just for the introduction, this the topographical survey we can also use. We can also continue the river basin master plan without the topographical survey. But why is it needed? Is like there are new technologies coming up. Before we used to do survey with using total station, taking the cross sections and all. Now there are developed and fast and reliable instruments like the DGPS and eco sounders, and the aerial technology like RTK, photogrammetry, and LiDAR technology, which we are currently using right now. This will help us in defining a good terrain for the hydraulic study. A good terrain is required because like as much as the resolution of the terrain is higher, then the hydraulic study also will be better. And it is essential for the watershed delineation and our estimation of other hydrological parameters. And it will also support in planning the like structures, embankments, and the river training work. Bathymetric survey is also required because it defines the real river profile and cross sections and the storage capacity, the elevation area capacity curve. And it also identifies the sedimentation and the scouring zones and also the erosion areas, which is very critical for hydraulic and flood modeling accuracy. From here, Mr. Balaji sir, who is the survey expert in here, will continue with the methodology and process and output of the aerial survey using LiDAR technology. Sir, please. Sir.
Good morning to all. Can you hear me? Yeah, fine. Myself Balaji, former researcher of IIT Kanpur, serial entrepreneur. I founded a company in IIT Kanpur with my professor on LiDAR technology, sold to GMR Group, one of the large infrastructure group in India, and then founded a second venture, Latex Aerospace. So here we work with the sensors and sensor technologies. For this project, I am working as a consultant, as a survey expert. I hope that many of you know that okay, survey, what is survey? So with that perception that okay, you know survey, so I am taking further. The survey is the okay, basically collecting the data of topography, earth. You want that okay? Now this here we are talking about not a other type of survey. We are talking about a civil related survey. So we are going to collect the earth data. So collecting earth data that okay, it's evolved over the 200 years. If you look into the Survey of India, it's already almost okay 225 years old organization where that okay it measured the entire India. It's created a first India map, land map. So survey is very much important that okay to know that what is the boundary, what is the depth, what is the okay contour levels, what are the features are there. Without the survey, we will not have a knowledge about our surroundings. That's the most crucial aspect. So, if you want to know about our surroundings, very simple example of the survey is the Google Maps. Imagine that okay, now, without a Google Maps, if you are getting into the new area, or new city, or new town, or new country, today it is next to impossible to navigate. So, the single location data helps us to navigate entire earth without having any fear or confusion. So that's the power of the data. That's the power of the survey data. So here that data is whatever the Google is giving us is just to give accuracy of 5 meter. It will be getting used only for a navigation. It's not for engineers. We as engineers, we need much more accurate, much more detailed, much more granular data. With that only we can do the planning, because why do we need a data? We need to first understand, then we need to plan, execute, and then change certain things, whether infrastructure, we will create a new infrastructure, or we will do work for the disaster management. So this data is going to help us to take some action on the field. That's why that okay, this is the most important and crucial aspect of any study. So here I am happy to introduce you a LiDAR technology. LiDAR is a very powerful technology. So we know that okay, what is photogrammetry? Daily we use the cameras. The camera, we capture the images. That's a photogrammetry. There are two major technologies which can capture the real world as it is with the highest accuracy and bring to the computer. Then we do analytics. So these are the competing and complementary technology. photograph, we know that. Okay, can we take a photograph at the night without a light, without any source of light? We cannot take, because photograph will be the dark, because there's no, because photographs is a passive technology. It needs a something like a sun light, so that okay you will get the information, otherwise you will not get the information. Here there is a alternate technology. It's a LiDAR. It stands for light detection and ranging. We would have heard that radar, radio wave detection and ranging, because that's a little older and then wider accepted and wider known technology. So in all the aircraft, we say that okay, all the military establishment radar. So with the radio wave, they do the detection. Here, with the help of laser, the detection and ranging. Ranging means measurements. So we know exactly what is that, okay, the whatever the object, whatever the feature is there, then we can measure accurately. How many of you use the laser distometer, distance measurements? There will be small laser distance measurements instrument. So just by you click, in the presentation people use similar to that, but when you click, it is available in Amazon also. You can check. So when you click that, okay, what is the distance between from me to that, okay, the wall? It will accurately tell. You don't need any tape. Otherwise, what are the other way to measure? You need a tape. Somebody has to hold this end, somebody has to hold that end. Then only that, okay, that also that, okay, there will be some error. When you have a distometer, you don't need anybody. Just wherever you click, it will show you the distance. And then there's a distometer with the level. Now there's a problem will come that, okay, now when you have measuring something in the angle, the distance will not be accurate. So there's a distance meter that, okay, with the level. So it with a single person, he can measure entire, okay, this rooms accurately with the millimeter accuracy. So that's the power of the laser. So from that distance meter, it is evolved the LiDAR. LiDAR is also having having a distometer, and then it's firing from the air, capturing the return. But in the distance meter, it is a single pulse laser. Here per second, from you can keep it from 4 lakhs to 20 lakhs measurements. Imagine that, okay, in a second we can do 4 lakh to 20 lakh measurements. That many number of measurements. If you compare with the GPS, for observing, even if you are observing GPS points with the RTK, it will take 1 point, okay, minimum say 2 minutes, 3 minutes that, okay, you observe and then take a XYZ. But here with the LiDAR technology, it will capture 20 lakh GPS points in a second. So all these 20 lakh GPS points we bring to the computer, create the geometry of the earth, because it's a 3D measurements, XYZ coordinates. How to go to the next slide? Yeah. So when we talk about a LiDAR, definitely we have to talk about the photogrammetry also. I told that, okay, now photogrammetry is a competing and complementing technology. Photogrammetry is a simple, we can take a photos with a, okay, with some distance and then bring us our eye as a stereo, because if you have a generally that, okay, if you close your eye, you will not be able to see the depth, because already if you are familiar with that area, it looks like that, okay, you know, with this, you can measure that, okay, with a single eye as a depth, but it is not reality. When you go to the new places, because your brain already does not have any memory of that place, so with a single eye you will not be able to get a depth. Same way, the photograph, single photograph is a 2D. When you take a 2 photographs with the overlaps, it can create a 3D. So with that 3D also we can do the measurements. The first technology is a direct measurements. Here we take a photograph, we do the computational model, we can create the same 3D. It has a visualization because a LiDAR, the laser measurements, it will not have a colors. So visualization side it will be a challenging. But photographs, it is very familiar. We can easily visualize, understand that. That's why I say that okay, it's a both as a complementary and competing technology. So what next slide? So what are the advantage and disadvantage of these technologies? You can see that okay, now there's a top image, there's a tree. There's a bottom image also, there is the same tree. Top one is measured from the LiDAR. The bottom one is measured from the or created from the photographs. So what LiDAR does, because it's an active technology, it can send the laser pulse. It can measure the below the tree and then it can the laser can hit the ground and then get the return. So you will get that entire profile of the tree. Even at dense forest, you will be able to get the ground data. In the photogrammetry, you will get the top of the tree only. You will not be able to get the ground data because photos only whatever it sees, that only you can measure. You cannot get the depth. LiDAR can get the depth. So tell me that okay, northeast and this region, which technology is suitable, whether photogrammetry or a LiDAR? Why? Because entire northeast is covered with the lot of trees. So if you go to Rajasthan, there photogrammetry can work because that okay, the most of the areas does not have a tree. So there is a LiDAR or a photogrammetry. Both can be that okay, give a same accuracy because the open land. If there's a ground, a school ground, if you measure with the photogrammetry, if you measure with the LiDAR, both will be the same. But if you go to the garden of the same school, measure with the LiDAR and measure with the photogrammetry, both will not give the same results. That will give the top of the garden, that what are the bushes are there, LiDAR will give the ground. But engineers needs the ground data, not the top of the tree, top of the bushes, top of the greens. So that's what that okay, in this project, even though the project allow us to do the photogrammetric survey, considering the okay, the importance of this project, we have taken that okay, no, we will do the LiDAR survey because this is a national important project and then there is a data and accuracy is much more required. And then we thought that okay, we are happy to introduce the LiDAR technology to the Brahmaputra board so that okay, future projects also will be that okay, come with the very accurate results. That's what okay, we have taken and then we have completed the entire data capture of the 3,600 square kilometer of river basin. So here is another very good example. You can see there is that the in center you can see there is a large tree. Under that okay, you cannot see the center photograph. You can see that okay, there is a very large tree, but we think that okay, nothing is under that tree. But that's the beauty of the LiDAR. There is a structure under the trees, so you will be able to get that exact structure under the tree. So there is no that okay, assumption here. With the LiDAR, you will not okay, assume anything. You will be getting the reality, real picture in the both X, Y and Z as it is. So coming back to that, okay, there is a I told that okay, there are two technologies, but still that okay, we have to do on ground work. It is not only air. We have to do some work on the ground. That's why that okay, the earth as a mathematical model in the both the technologies, there some computational mathematical model will be used. So when you use that okay, you know the concept of ellipsoid, geoid, because ellipsoid and geoid, this mathematical model considers earth as a proper shape, but earth is not having a proper shape. The elevation, there is a elevation difference and it is a irregular shape. So we have to whenever you are doing a large project, large area project, to bring that the data to that match with the ground, we need to have a benchmarks. I think you know very well that about Survey of India benchmarks. That is a accurate. It's a represent the accurate elevation data of the particular site. If you go to the any railway station, if you go to that generally in the bridges or PW offices, irrigation offices, even at the dams, there will be a mark of that only Z. This is that elevation point of that particular the location. So what we want this data to be sitting exactly, because we are engineers. So we do not want that it's a 1 meter. We want that 10 centimeter, 20 centimeter. So we have to bring that data, whatever we capture in the air, it has to exactly sit on the ground. So there are many reference datums. Each country follows the different reference datums. We follow that Survey of India reference datum. That mostly that benchmarks we take and then we work on that. So we will be that first identify the already established benchmarks and then transfer those benchmarks to the project site and then make use of that and then create these 3D data sets. So we need to also, when establishing the benchmarks, we need to also establish the XY accurately. So there is a horizontal and there is a vertical control. The horizontal control will come from the DGPS. I hope that you know that what is GNSS, what is DGPS. DGPS measures a single point with the centimeter accuracy. So we use a DGPS control points to ensure that we are having the data of a 3000 square kilometer or single river basin having a proper reference system. So for that we create the network of these GNSS stations and then connect with the Survey of India benchmarks. So here as per the project requirement, every average 50 kilometer we will have a master control. What is master control? These master controls are observed over 3+ hours. So when you observe with the GPS or GNSS over the 3+ hours, you will get the data close to the accuracy of less than a centimeter. So that's called master control. Then there is a secondary control. Those are the observed 1 hour. So when you observe that one, it will come close to that close to the 2 centimeter kind of accuracy we will reach. So with that master control and then secondary control and then with the benchmarks, we establish that the entire area on the particular reference accuracy. So when we capture the data, this data when we capture the either photos or whether LiDAR, this data will help us to translate to the actual earth coordinates, our requirement, our local coordinate system, and then check the accuracy. It acts as the two reference. One is that convert the data, whatever that data we capture, that will convert into our local coordinate system. Second thing is that after conversion, is the data is right or wrong? To check the accuracy, the same control network, few checkpoints will help us. So there are specifications how to establish the master control, how to establish that the secondary control. This is the primary benchmark. There is a dimensions are given. This is goes with the standards of Survey of India. How to establish your, because this should not be disturbed. This is that over the years, next 10 years, 20 years, when you want to start the project. See now what we are doing a analysis. We are going to find the way that okay solve the problem. But at the end of the day, how the problem will be solved once you construct or once you take action. When you go for the action, again you need a same reference, because whatever the reference we worked, whatever the reference that we established the analytics, the same reference required on the ground. That's where this master controls will help. Even you go after 5 years also, this point x, y, z will not be changed. So you can easily again take that okay point and re-establish the control networks. That's what the purpose of this master control. Then there's a temporary or secondary control. Wherever you want a 10 kilometer, this is a temporary. That means for the project purpose. It will be that okay for a year or a two. After that, okay, somewhere it will get disturbed. It's not. It must not be that okay, permanently there, because every permanent one costs more. So we need a few permanent one. Rest of the things are the temporary controls. So now coming back to that okay aerial, what we have done in this project, we have captured this entire 3,300 square kilometer from the helicopter, flying at the a kilometer away from the actual terrain. We fix the LiDAR, we fix the camera, we fix the IMU, GNS. There are all these systems together, because LiDAR is not a single technology. You need to have a GNSS or GPS that will give you the accurate coordinates. There is another sensor is called IMU. It will give a orientation of the aircraft or helicopter. It's called roll, pitch, yaw. Then there's a camera. Then there's a laser. So all these things put together going to give you the accurate 3D representation of the terrain. So the most important advantage of LiDAR, it has a multiple return. What is a multiple return? If I fire the laser, in the laser that okay, we imagine that it will be a single point, but laser when it travels to the longer distance, it will be a single point. It's like our torch. So torch, what will happen? The light will diverge, so it will become a big circle. At the starting point, it will be a point, but when it's travel for a longer distance, it will become a larger circle, larger footprint. So when it falls here, example that okay, it falls from the floor, it will get a single return. Just okay, it got that okay, fallen on the floor, it got the direct. But imagine that okay, the part of the footprint is falling on this table. What will happen? From here also there will be a return, but part of that okay, footprint will fall on the ground. So that will also have a return. So this is called multiple return. If the laser that okay sensor has a multiple return ability, then it can measure that okay, even it can go through the trees, because trees will have gaps. So it will fall on the trees, leaves, branches, and then ground, then it will get the return. So the multiple return is the minimum 3 return is the required. So that okay, you will get the ground data. So multiple return ability is the most crucial aspect of the LiDAR, which will give the ground. So when we do that okay, any aerial projects, we ensure that okay, we have multiple return that ensure that okay for us the ground data. So this is that okay, little technical, but I try to make it simple for your understanding. So anything that okay, you start with, you need a mission strategy and logistic plan. Any survey or anything that okay, you want to go to that okay, example one tour program, we want to go to that, say that okay, Europe. Want to do travel with the family, Europe. What we will do? That okay, we will find that okay, what are the things we have to do? We have to write. We will say that okay, whether our family has the visas, whether the family has first passport, then there's a visa, then which destination we have to go first, which destination we have to go, Second, so we will have a planning. So that same similar things that okay we do also here the planning. Then which that okay season we have to travel. For example, that okay now we would like to travel Shimla in certain season and then Rajasthan in certain season. So that's where that okay now. So here also the same thing. We need to understand the environment because before the mission starts, the first thing is that first and most important parameter is the weather. The weather, okay, now, can you do that okay aerial survey in the rainy season? You cannot do. Can you do in the foggy season? You cannot do. So you have to understand that okay that particular region, what kind of weather pattern is there, how much time that I will get a clear sky to do the survey, and then we have to do the flight parameters at what speed I have to fly, what height I have to fly, what kind of okay the permissions that okay because there is a nearest airport, nearest defense infrastructures, we have to understand and then plan these activities. Then okay from helicopter or aircraft going from one location to another location, how will I refuel? Because even that okay, the car we are taking the car, we know that okay after some distance we have to fuel. So we will always see that okay whether the fuel station is there or not. The same way that okay we have to plan each and every activity because this is the brain of the entire that okay survey mission. So first you have to plan step by step. So then your mission will be successful. Here any issues, any gaps will cost you the money, cost you the delay, cost you that okay the overall project suffer on even accuracy side also. Then there is a ground setup and technical readiness. So whether that okay all our hardwares are ready and then it is calibrated, is in working condition. If you have to travel to that okay distance, see when we are traveling within the city, we will not check the car, we will not worry about that okay car's condition. But if you have to travel 1,000 kilometers, will you travel with that okay same mindset? What you will do? You will go and do all the pre-checks whether that okay alignment of the wheel is proper, there is that okay the air is there, all the checks we do. So here also the same thing that okay all the technical aspect. First thing is that executional aspect. First we have just to done the strategy, but when you are going to the execution, you should know that okay what are the, because it's not a single instrument like a GPS. We have a laser, we have a camera, we have a IMU, we have a GNSS, we have helicopter, we have that okay multiple screens. So everything that okay we have to ensure that okay everything optimally working, properly working, calibrated, and then okay the sensors are synchronized because one sensor has to communicate to the another sensor. If it's not communicating, you will not get a required output. So all these things that okay technical readiness you have to do in the ground, check up on the ground. Then execution and in-flight monitoring. Okay, now that okay we have done the strategy, we have done the mission planning, we have done the okay ground test, everything we have done. Now that okay we move to the third stage of the project, execution and then in-flight monitoring. That means helicopter started from the base and then started flying, but still we monitor that okay all the sensors are working, whether cameras are getting captured, lasers are getting fired, it is getting the GPS, because any small issue that okay your entire mission will be that okay wasted, and then again coming back and flying going to be a very costly affair. It is not that okay the not only technology, it every steps involves lot of manpower, money. So you have to ensure that okay everything is working properly. So you have to actively monitor the dashboard on the coverage. Okay, we plan that okay to cover the say 200 square kilometer. So the 200 square kilometer is covered or not. Without checking that okay you come back and what will happen? Again that you have to refly. So you have to have that okay every where you have to have a checks. So how that okay data security and operational closure. We say that okay the data, the 3D data is a digital gold. So per day, for giving you a rough idea that okay operational cost of the entire exercise will be a 10 to 12 lakh rupees. So imagine that okay, now we lose the data. That's all. That okay, then the entire again you have to refly. So a day that okay operational cost is very high in this kind of technologies, and then but that together it will give you that okay lot of benefits. So you have to ensure that the data is secure, data is proper, data is secured, it is validated and then handed over. So that's what that okay most important aspect. So you have coverage, okay, you have done a proper coverage, the data is the quality, and then you have to hand over, okay, who is the responsible person, and then you have to have a 2 copies, and then you have to shut down the base stations, and then you have to say that okay today operation is called off. So that's a part of the data capture. So now that okay, now see, but data, whatever we capture from the air, but we need to use, we need to see the results. So that's called that okay data process. Now that okay we captured the image, but that okay we need that image to be beautiful. What we will do? In the photo that again like a normal okay cell phone or a mobile phone we capture the image, we will be satisfied. We'll take to that okay some Photoshop or some software, then we will make it beautiful, we will make a frame, we will make that okay some modification. Same thing here, the data we have, that same data we have to that okay process, we have to, because there is this data is from different sensors. So that, but what we need is unified data. We need that okay, we need to able to read. That's in the machine language. We cannot read. What we need okay, our own language, our own mother tongue or English or Hindi we need, so that okay we can read, we can make a sense of that. That's called that okay data processing. With that okay we refine that okay entire data together, and then we will generate a contour, DEM, digital elevation model, digital terrain model, so that okay these data are the engineering data sets. This will help us to study that entire terrain. After generating the data, there are standards. Okay, so how we can sure that okay that I generate the data is not that okay simply beautiful data. I do not want. I want the data to be accurate. So I have to follow certain standards. There are ASPRS, ISPRS, or Survey of India. There are international standards are there to validate the data is accurate or not. So we have a control points, we have a checkpoints. So we will let bring that checkpoints to the data. So then that data is matching or not properly. We assess, and then we once that okay it meets the accuracy, vertical and then horizontal accuracy, then we close the project. We hand over the data to the client and then close the projects. So there are deliverables like a ortho mosaic, digital terrain model, and digital surface model, and then contours. So ortho photo, because most of you using a Google Earth also, you will know that okay what is the satellite image. Ortho photo is similar to that okay satellite image, but that okay each building looks vertical. You look in the 90-degree, each building should look vertical. So that's called that ortho photo. There is a DSM, digital surface model. A digital surface model is very simple way. How I can explain you that okay you take a blanket, a large blanket, and then put it on this entire okay the campus. What you will get? You will get a very unified surface. You will not see anything, just okay a blanket wrapped on this entire surface. So you will not get any minute detail, but it will give you that okay the height, and then what is the lowest point, how many trees. So it's a complete blanket on the terrain. So there is nothing we have removed. So that's called the digital surface model. It has its own utility. I'll come back to you later. The third one is a digital terrain model or digital elevation model. What is the meaning of that? I have to remove all the above ground features. I don't need a building. I don't need a tree. I don't need a bridge. I don't need anything man-made, anything natural features above the ground. I need the moon surface. Nothing there in the moon. So same thing that I want the replica of the that earth. Say we say that okay, 10,000 years, 20,000 years, or 50,000 years before, whatever there. So that simple ground data, nothing will be there. That because that ground data is the most crucial. That data will be used for the most of the engineering application. You want that okay, cut, fill, construct everything that okay, you have to do in the ground. You will not work on the building, you will not work on the tree, you will not work on anything. You will remove everything and then create that okay, the space for a construction. So that's where that okay, this digital terrain or elevation model gets used. So this is a sample data of the Dikrong river basin. So it's almost 420 square kilometers captured. In this top one is the point cloud data. The right one is that okay, that's called DSM. I told that okay, digital surface model. So you can see that okay, there's a minute difference in this area. You can see a lot of okay, small undulations. But we removed everything and then we created the digital elevation model. Then the contour. The contour is a line of equal elevation. So wherever that okay, you have the 100, so the line will cross the 100. Wherever the 105, line will cross to the 105. So that's the simple representation of the elevation where you can work on the AutoCAD drawings. This is that okay, another point cloud view. How that okay, the thing, even you can see the beauty of the electric lines. This is a large electric line is crossing this area. You will be able to see that okay, even the beauty of the LiDAR technology, you will get that even electric lines, high tension lines, perfectly you will get. This is the orthophoto and contour, a sample orthophoto and then contour of this. So this is a Bathi survey we have conducted. So underwater survey, because when you have a topographic feature from the LiDAR, from the aircraft, but LiDAR cannot penetrate water. The LiDAR, the frequency we operate is an infrared range LiDAR. The water absorbs the infrared. So you will not get any return from the water. So wherever water is there, there's a technology called echo sounder. That echo sounder, what that is sound wave, simple, like how there we are using a laser, here we are using a sound wave, sonar. So sending a sound pulse, that okay, it will get that okay, the return. So from that you can measure that okay, the accurate depth of the water, so that again the bed, river bed also important, because now we have above ground and then river bed put together give you the complete picture of the terrain. So that's what that okay, we have already completed. Now we are in the process of the okay, starting the analytics on the data. Within next 3 months we'll be able to share you that okay, complete master plan sample and basis, how that okay, what we envision, what that okay, the Brahmaputra board envision on this entire master plans. We will be submitting you in the coming days. I hope that okay, I am able to explain you with the simple terms, whatever the possible way I tried. If you have any queries, please reach me. Thank you for giving me this wonderful opportunity. Spatial resolution, either one time you are taking. So spatial resolution is called PSD, that is pixel. Whatever the pixel you are taking, pixel size is called spatial resolution. In the camera, take this is 5 centimeters, 10 centimeters, 20 centimeters, take satellite images, 30 centimeters satellite images, or 60 centimeters satellite images, or 1 meter satellite image. So this is called a spatial solution. Temporal solution is that okay, the same place, how many times you have taken, and then in the year of our month frequency. What is the frequency of taken? So now that okay, I want to monitor this cohort every month. So I capture that cohort every month again and again and again. So my temporal frequency is a month. That's a frequency. Temporal resolution is the frequency of revisiting the place again at the same interval.
And sir,
Oh, sorry. Yeah, I always walk in there. My voice is loud, so they'll not very proud. Yes, I always when talking now. Walking is just.
Arpita was using that column mic.